Imagine if you could gather the energy from every star within 100 million light years, from thousands of galaxies, each with billions of stars. Imagine you could take this kind of power and use it to fire the biggest superweapon in the universe. Imagine the damage you could do. It turns out, you don't need to imagine it. These exist, and they're called gamma-ray bursts. But what are these cosmic snipers? And what happens if one takes a shot at Earth? To understand gamma-ray bursts, we first have to understand gamma rays. Gamma rays are electromagnetic radiation, waves which carry energy just like visible light. Visible light is a tiny part of the electromagnetic spectrum. It's the part your eyes can see. At lower energies, there are radio waves, microwaves, and infrared. And at higher energies, ultraviolet, X-rays, and gamma rays. Gamma rays are incredibly powerful. A single gamma ray photon is more energetic than 1 million visible photons combined. Their high energy makes gamma rays a form of ionizing radiation, meaning they are energetic enough to break apart atomic bonds. This makes them dangerous to you and me. Ionizing radiation disrupts the delicate biochemical machinery that keeps us alive like a 9mm bullet through a clock. Fortunately, on Earth, the ozone layer blocks gamma rays, filtering them out before they can harm us. But if the atmosphere blocks gamma rays from space, how were gamma ray bursts, or GRBs, from space ever discovered? During the Cold War, the USA sent up spy satellites which could detect gamma rays from Soviet nuclear tests in space. They didn't see any bombs, but they did observe faint bursts coming from space, lasting only a few seconds. To date, this may be the only major scientific discovery made by spy satellites, that we know about anyway. Astronomers use telescopes that see different kinds of light to make their discoveries, and these spy satellites gave them a new pair of eyes. They were a mystery for 30 years, but eventually we discovered the source of a GRB, a galaxy 6 billion light years away. If a GRB can be seen from such a distance, then it must be incredibly energetic, releasing more energy in a second than the Sun will in its entire 10 billion year lifetime, making GRBs the brightest events in the universe. So, where do they come from? GRBs accompany some of the most violent cataclysmic deaths in the universe and the birth of black holes. There are two types of gamma-ray burst, short and long, and each has their own source. Long GRBs last about a minute, and scientists think they are produced by supernova, when the core of a massive star collapses to become a black hole. Short GRBs last a second and are produced when two neutron stars in a binary merge. Over millions of years, their orbits decay by emitting gravitational waves. Once they're close enough to touch, they crash and splash into each other, forming a black hole. Both supernova and neutron star mergers make the same thing: black holes surrounded by a magnetized disk of gas left over from their parent stars. In these environments, the rotation winds up the magnetic field, which funnels hot jets of particles traveling at nearly the speed of light. The gas in this funnel creates two tight jets of high-energy gamma rays, like a celestial laser gun. So unlike other cosmic explosions which spread out and fade, GRBs stay focused and can be seen from much further. Any more detail would require too much mathematics for a YouTube video. The universe is full of these cosmic snipers, firing blindly and randomly into the dark, and they're hitting us all the time. On average, we detect one per day. Fortunately, most are harmless. All the bursts we have detected so far originated outside the Milky Way, too far away to hurt us. But a nearby GRB could be disastrous. If one goes off within a few light years of us, it would totally cook the surface of the Earth, or at least the half that's facing it. But even a more distant GRB could still end life on Earth. And it wouldn't need to score a headshot to kill us. If originating from a few thousand light years away, it would be 100 light years wide by the time it reaches us, washing over the solar system like a tidal wave. Again, the ozone layer protects us, but it's better equipped to handle the trickle of ultraviolet from the sun. A gamma-ray burst would overwhelm it, leaving us exposed to deadly solar radiation. Ozone takes years to replenish itself by natural processes, which is more than enough time for the sun to burn the Earth sterile, or at least to kill most complex life. In fact, this may have already happened. A GRB has been suggested as one possible cause of the Ordovician extinction 450 million years ago that eradicated almost 85% of all marine species, although it's pretty much impossible to prove. Gamma-ray bursts could even be one reason we don't see life anywhere else in the universe. They might be wiping clean huge chunks of it on a regular basis. It's been suggested that because of GRBs, only 10% of all galaxies might be hospitable to life similar to us. So, are they going to kill us? Probably not. In a galaxy like ours, there may only be one GRB per millennia, and to harm us, they must be close and directed at us. But since gamma rays travel at the speed of light, we won't know one is headed our way until it arrives. So there could already be a GRB on its way to kill us all, and we won't know it until it hits us and we're dead. This video was sponsored by Squarespace.com/nutshell. Death from the sky could come around any second, maybe even now. So you don't have any time to waste. Learning to set up a website, portfolio, or blog is usually hard and time-consuming. Not so with Squarespace though. They let you set up a page with easily understandable tools very quickly and without any knowledge of web design. You can use the code NUTSHELL to save 10% and support Kurzgesagt. Squarespace have been a great sponsor, so give them some love. You can support us directly at Patreon or get Kurzgesagt merch here. It really helps. Over the next few months, we'd like to make more videos about cataclysmic destructive events because, honestly, it's a lot of fun to make these. If you have any ideas about what kind of doomsday scenario you'd like to learn about, let us know in the comments. And if you need to kill a little more time now, here are a few related videos. Or maybe now.